3 times 1 over cosine squared x minus 4 equals 0. Love it.
Sorry.
Sorry, what?
No, just kidding. Multiply it. Multiply this together.
Multiply together, so I get 3 over cosine squared x minus 4 equals 0. Perfect. That's a step where some people can get in all kinds of trouble. We're trying to get used to adding fractions. I'm trying to solve this. I just want to get things to the other side and away from this thing. Right? That's a better step. Cosine squared, right, to get off the bottom. Still want to solve for x. What do I got to do? Divide both sides by 4. Look at you. Now we're going to get rid of. I got to get rid of the what? The squared, right? How to get rid of squared? No. Plus or minus the square root of it. Don't give me that look. I've graded an awful lot of tests in my day. I was grading tests before you were born. That's fun to say. I've never tried that before. Now, I can't have a square root of 4 on the bottom. How do I get rid of the square root of 4 on the bottom? Yeah. Although distribute's the exact wrong word. There's math teachers right now screaming that. And I say, yeah. And they're like, what? But I like it. Distribute the bottom. So where does cosine x give us? Plus or minus the square root of 3 over 2. That one sounds familiar, so it's probably on our chart somewhere. Yeah. 30 degrees. 30 degrees. Where else is it positive? Cosine, yeah. 300. 330.
So does it, how do I know that it's 1 degrees? Like,
I have to tell you. So in this problem, it does not say that.
So for all real values of x.
For all real values, you get to pick. And I suspect most people are going to pick degrees. You could pick radians, and it'd be totally okay. But we're not done yet. We've done the 2 positive ones. We also have 2 minus ones, don't we? What are my negative ones? 150, I love it. Plus or minus, right? So I have to do the negative root 3 over 2.
You take it away.
All right, well, it's 30 degrees, right? So I'm going to be 30 degrees this way, because I know it's negative in my second quadrant. It's going to be 30 degrees here, so it's going to be 180 plus 30, right? So 210. Are we done yet? Read the instructions. The instructions say for all real values there. Here we go. X equals 30 degrees plus 360 degrees Z. And what?
Could you do plus 180 degrees?
Yes, you could do this. You could lump those together and lump these together as 180 degrees. Totally. I'm not expecting anybody to do that, but if you do that, it's totally 100% okay. Totally not just okay. Good. Yes, ma'am. Because it's plus or minus, right? So the plus gave me 2 values, because there's 2 places where cosine's positive, this one and this quadrant. And there's 2 places where it's negative, so this one and this one. Okay? So then it's 150 degrees plus 360 degrees N, and 210 degrees plus 360 degrees N, and 330 degrees plus 360 degrees N. Where N is equal to ... negative 1, 0, 1, 2, ... Oh yeah. Oh yeah. Isn't that fun? Look at that. No. Mean would be to make you write all those things. Then I could go home. Because you guys wouldn't get done. There's an infinite number of answers. Dirk's like, no, I could write them all down. Don't try it, Dirk. Don't try.
No, I meant all those. Like that.
Isn't that fun? Now, he did a shortcut that might apply to you. He knows that 30 and 210 are 180 degrees apart. Then the next one will be 180 is more. So you could write this as 30 plus 180n and 150 plus 180n and only cut out these two. That doesn't work every time. You have to think about it. And so if you like that, do it. If you don't, stay away from it. Write before. I know it's going to cost you a little extra graphite, but it's probably worth it. You have some to spare. All right, what do you got?
Just move the cosine x to make it 0 on one side.
We can do that. Not really sure why we're doing that. We usually do that when we have quadratics. Is this a quadratic?
Oh no, because there's
No. So now what do I do? Well, this is too easy. I want to solve for x. What do we do?
Add 2.
Add 2, yeah. Got 2 equals 2 cosine x, yeah.
Divide by 2.
Divide by 2, 1 equals cosine x, all right. Where does cosine give me 1?
At 0 degrees.
At 0 degrees. So we're feeling really good, aren't we?
That good?
Yeah, look at that. Now read the instructions, right? Is it from 0 to 360? Is it from 0 to 2 pi? Is it from all answers? What does it actually say?
Express solutions in degrees.
And what else does it say?
Solve each equation for principal values of x.
For principal values. It doesn't say 0 to 360. It doesn't say all values. It says principal values. That's a new phrase. It has meaning. Oh, crud. Something new to learn. Let's do it. What's new to learn here? Principal values are what your calculator does. Okay? Long time ago, I told you your calculator lies to you. It's not strictly speaking true. It's just not. It is actually, because it's a rock, we can call it dumb. It actually doesn't know what's going on around it. It can't look at the picture of the graph, and it can't figure out what is going on. So it just simply solves for what are called principal values. You're going to like this because instead of having 2 answers, we're only going to have 1. Okay? Principal values is 1 answer. Now, for principal values is as follows. For cosine, you're going to need to write yourself a little chart, a little something. Get ready here. For cosine of theta, if I'm trying to find my angle, I only get to use from 0 degrees to 180 degrees. That's all I get to use. So find me all the answers from 0 to 180. That's what it means for cosine. That's what principal value means. Okay? Sine and tangent have a different rule. Sine and tangent you must solve from negative 90 degrees to positive 90 degrees. Good question. That's what I'm going to discuss next. Now, first of all, why have 2 quadrants at all? Mr. Durr, why do I need 2 quadrants?
Because they're both positive.
Because I need a positive and a negative one. I need one that's negative and positive, right? So this is positive, this is negative for cosine. This is positive, and this is negative for both sine and tangent. That's why I need 2 quadrants to begin with. Now that I have the quadrants set up for principal values, why is cosine like this? Well, because I need a positive and negative. If I did this one, it would be a problem, wouldn't it? It would be a problem. It wouldn't work because I'd have 2 positives. All right, sorry. Yes. If it was cosine, when it goes up, it would be positive here, so I have to have 2 different answer rules. Now, that's the first reason there's difference. Now, the second reason is this. Principal values came up because of your calculator. Yes, because of your calculator. Because your calculator, it was easier to program it to find this quadrant and this quadrant than this quadrant. This why? Just think about it. When your calculator tries to find the principal value, what does it find? Let's say I want to find sine theta equals negative 1/2. Your calculator, when you put it in there, will say that's what? If you're not in radians, you're in degrees. What does it say? Negative 30 degrees. Now, why did they pick negative? Well, because it's going to get 30 degrees for the half. And then the minus sign, it just slaps on there and calls it a day. Makes the programming that much easier. And that's why we use from negative 90 to positive 90. Likewise, if you want radians for this, you would use 0 radians and pi radians, or you would use negative pi over 2 to pi over 2 radians. Okay? But almost always when you do principal values, you're going to use degrees, so it's not going to matter. So far, so good? So what's my final answer, Mr. Alonso? Where's cosine 1 from 0 to 180 and only there?
From 0 to 180. 0.
0 degrees. That's it. We're already done. Done with the problem about an hour ago. Okay? It's the only place where it's going to be true, right? I don't have to check. You know, normally to check, oh, but what about where else cosine would be? 0 degrees. Where else would it be 0 degrees? Should be 180. Must be not including 180. Because it should have only one answer. That's a weird one. What a bad one to start with. That's terrible. All right. Try number 2. Oh, you like it.
Gone from extra work to very much less work.
Right, but we hadn't talked about principal value before, so. Plus, you don't appreciate it. It just sounds confusing if I just start with it. If I end with it, you're like, oh, take goodness, I don't want to write down that huge page of stuff I just wrote a second ago. So that's great. We need principal values every day. Try number 2. Yes, sir.
For the science, the way I changed it to. Wait, actually.
Why would you do that? Whatever you just said, don't do that. No. Stop. Before you hurt somebody.